Hey guys, the topic for this video is slightly advanced and frankly not many people know about it. If you are a data science or a machine learning practitioner, you may have heard of the terms linear regression and gradient descent. Well, if you're someone who's not, then basically these are like the ABC of machine learning. So while studying linear regression and using this linear model SGDRegressor library for the first time, you may have heard or even read somewhere that it uses gradient descent in its backend. Well, it is not true. In reality, it uses another method called normal equations, or more specifically, the singular value decomposition, or SVD. This normal equation method uses linear algebra and matrices as compared to calculus and derivatives in gradient descent. I won't get technical and get into the math of it. I'll leave a link in the description for you to refer. Well, in this sklearn library, or the scikit-learn library, which is like the most common machine learning library in Python, you can implement both of these methods. So here I have the documentation for the methods. The first is the sklearn linear regression, and the second is the sklearn.linear model SGDRegressor. First, let us have a look at the linear regression model. So it reads here that it uses ordinary least squares linear regression. Let me quickly open the source code and let us concentrate on the footnote on its docstring. Here it is. So it says that from the implementation point of view, this is just plain ordinary least squares from the scipy.linalog.lstsq or this non-negative least square blah 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 wrapped as a predictor object. So what it basically means that this method is using this scipy.linalog.lstsq method to predict. Now I have also opened the documentation for this scipy class, and here it is. Let me open the source code for this too. And let me explain you what the docstring is saying. So it is saying that it computes a least square solution to equation ax equal to b, where a is my coefficients, x is my variable values, and b is my final outcome. It computes a vector x such that the 2 norm b minus ax is minimized. So 2 norm is basically the Euclidean distance or the under root of the square terms. B is my observed value and ax is my predicted value. So this term, the 2 norm, this is basically the cost for a regression task. So now you know that this sklearn object linear regression does not use gradient descent, rather uses this normal vector equations. Now speaking of gradient descent, you can implement gradient descent in sklearn using this SGDRegressor. So let me just quickly read what the documentation says. It says that SGD first of all stands for stochastic gradient descent. The gradient of the loss is estimated each sample at a time, and the model is updated along the way with a decreasing strength schedule, aka learning rate. So I'll not open the source code. You can I'll leave the link in the description. You can read, you can go through it if you want. And here is a great article I found on the Jovim website forum on the same topic. Do give it a read if you like to know more about the topic. Now you must be thinking that does it really matter what we are using to perform a regression task? Well, it doesn't matter if you are practicing or doing mini projects where data sets are quite small, as both of these methods will yield almost exact results. However, the first method, which is the linear regression from this sklearn linear model library, is not efficient and optimized. When a data set is huge, like in hundred of thousands or even million records, then it is not feasible to load all this data in the RAM, and matrix operations become computationally slow and expensive. In such cases, this SGDRegressor will outperform sklearn and give us better results, because in this SGDRegressor object, you can batch your data, like send it in groups to the RAM, so there is no memory overload. So go ahead and use whichever you like if you're just practicing, but you should know what is going in the backend to avoid possible pitfalls and maybe sound a little bit smart. If you guys want code implementation, so let me know in the comments. I'll make a video about that. Thank you for watching, guys.